Okay, so hi everyone, Senan this side, and in this video we are going to solve this LeetCode daily problem, which is count the number of consistent strings. The problem is quite simple, so I won't be doing the dry run of this on paper. So let's go through this question and I'll make sure that you understand each and everything that this question is asking. You are given a string allowed consisting of distinct characters. Okay, so this allowed string is having distinct characters and an array of strings words. So you have a list of strings or list of words. So we need to count the consistent strings, right? So what is the definition of consistent? So consistent if all characters in the string appear in the string allowed. So every word that you see here, any word that you see here is consistent if it is composed of the characters present in this allowed string. Okay, so we have to return the number of consistent strings in the array words. So allowed is AB and in this case AD. So D is not in allowed, so this is not consistent. BD, B is there but D is not there, so it's inconsistent. You see this, we have 3 A's and 1 B. So we have A's in this allowed as well as B. So this consistent. So count is till this index, count is 1. Now BAA again, B is there, A is there in this allowed string. So BAA is also consistent. So we have two consistent strings till now. Now we see BA, DAB. So B is there, A is there, this A is there, this B is there, but D is not there. So this is inconsistent. So we return 2 because we only found 2 consistent strings. Now let's look at example 2. ABC. A is there, B is there, C is there, AB is there, AC is there, BC is there, ABC is also. So all the substrings, subarray of this ABC is in this list. So the number of consistent strings are. Similarly, you can do this for the third test case as well. Now, some of the constraints. The characters in allowed are distinct. So this allowed has distinct character. Words of I and allowed contains only lowercase English characters. Now, this is the thing that actually simplifies the problem. And the words of I length is less than 10, word allowed length is less than 26. Obviously there are 26 characters, so not more than that. And words length, the length of this list is 10 to the power 4. Okay, so how do we go about doing this? So the idea is to have a hash map. Why? Because it allows us for searching the elements quite easily. So if we are looking at this string and to check its consistency, I'll take the first character A and then check if that is present in this allowed string or not. Then I'll take D and then I will check if D is present or not. So D is not present, so I return false or something like that. So that is why we will use a hash set, so that would searching time would decrease to big O of 1. Now if this constraint was not given, that it's only lowercase English letters, or maybe it could have any other symbols and characters other than the English letters, I would use an unordered set or an ordered set. But since we know it is only lowercase English letters, what I can use is a hash vector. So it will have 26 elements and each will be initialized with 0. Now what I would do is for every character in this allowed string, I'll mark that as present in this letters hash vector. This hash array, whatever you call this, hash map, hash array, whatever you want to call this, I'm marking that as that character as present in this list. So ch minus a is basically doing the subtraction in ASCII values. So if ch is a itself, so this would be 0, ch is b, this would be 1, and so on, and ch would be z, so z minus a will give you 25. So what I've done is I've in this letters or this hash set or hash map, I've made that every element, every character, I've marked the presence of every character in this letters hash map. Now what I do is I initialize the count 0, and what I do is I try to search for this outer loop is for searching all words, right? So I take every word and do the search in that. Now I create a variable pool consistent equal to true. So what is consistent? It tells you that the word is consistent or not. Now what I do in this for loop, you see, I go to every character in that word and check if that letter is not present in this allowed list or in the allowed string. Basically I'm checking that is that letter ch minus a is present in this letters hash map. So if it is not present, that means we found a letter that is in the words but not in the allowed string. So what I do is I say consistent is equal to false and I break out of this loop. And for some reason, if I don't get inside this if statement, that means the word has all the letter which are present in the allowed string. So what I do, if consistent, I increase the counter and in the end I return the count. Okay, so the problem is quite straightforward, and if I just run this, this would be running, and look, this is accepted and beats 96.02. So yeah, what is the space complexity? Given the constraints, I know we have only 26 size vector, so the space complexity is actually constant because we are not depending on the length of this words list does not affect my length of this letters vector. So that means it's independent of the input size, so it is constant space. So what is the time complex? Time complexity would be the sum of all the characters present in this allowed as well as in this words. That is the time complexity, because we are going to through every character in every word exactly once. And additionally, we do the same thing for this allowed string as well. So yep, that was the whole video. It's quite straightforward. I don't feel that it's too complicated to understand, and you can actually do this for any other language as well. So directly you could use in Python. If you do this, you can directly search in this allowed string and that would do your job. So yep, that was the whole video and I'll see you in the next one.